We really still don't really have a satisfying theory of neural networks, nor do we know for sure what's hiding in a sentence or a document vector. So our last talk from our great speaker, Liad Magen, will explain several methods that can be used to gain insights between a model's input and output, and also present several novel ideas for incorporating a visualization of these models in these methods in a product. So please welcome warmly to the stage Liad Magen, data scientist and deep learning expert from WeAreDevelopers, to the stage with a big round of applause.
Okay. Hi, everyone. I don't know. OK, good. So not so much left to say after all the amazing lectures that we have. So basically, thank you for coming, and maybe see you next year. And in the meanwhile, since you already seen these chihuahuas that look like muffins, and here have some cats that look like bread, or maybe some Labradors that looks like fried chicken. So I guess we all are already tired after these 2 days. We want to go home, maybe watch some Netflix, look for, I don't know, Jurassic Park. I don't know if you ever noticed how Netflix is working. It's quite interesting. But when you're looking for Jurassic Park, one of the suggestions that it gives you is things that maybe you are interested in Sarah Jessica Parker, which was also interesting for me. I guess what it's doing there is some kind of similarity of characters, and that's why it comes into the result. But there's lots of interesting and peculiar and weird things that are happening in Netflix. For example, when you're looking for Paranormal Activity 2, it can suggest you some comedies like White Chicks. Or when you're looking for Monsters University, it can suggest you things like Making a Murder. So it's not so clear how exactly they're offering stuff. I don't know about you, but normally I don't really find something interesting to watch. I'm passing more time in looking for recommendations in Netflix than actually watching what I want to see. Also, now they actually changed the whole system. Now, instead of having this 5 stars, so instead of suggesting that maybe you would like this movie with 4 stars, now they say, now you only have this thumb up, thumb down, and then they tell you that you might, there's 95% match between you and this film. But what exactly does it mean, that 95% match? I mean, now if I'm in like a mood to see a heavy documentary, but the next day I would be in a mood for seeing something light, some light entertainment, or maybe I'm now into a long movie, and then tomorrow I'm into a series. It's not so clear what this 95% actually means. In other companies, the situation is slightly different. Let's say, for example, in LinkedIn, when you're looking at the matching of the jobs, they have actually 2 different sections there, if you ever noticed. One looks at the last job that you clicked on and gives you the results that are most similar to it. It could also last years. So if the last one I was clicking on, for example, it's a Java developer, it will be like this, like because I viewed Java developer a year ago, then it still gives me the stuff. They have another section that is actually a search engine, where you can define some features of your search, and then it gives you the most likelihood of the jobs that match to this search. And then at some point in the middle of all of this, they ask you, are these jobs OK for you? Now, this is the same thumbs up, thumb down. But this is not really training any model, as far as I can see, because there is no changes in the results. If it would have been a real response to the model, it would have been the same thumb up, thumb down for each and every result. But this is not the case. So what does it mean here? My assumption is some kind of an A/B testing, and they try to see if the search actually works or not. I don't know. I didn't check with LinkedIn. In Google, the situation is slightly different. In Google, when you are like, for example, if you Google Apple, then they have a really cool thing. They show you these chips and these options or buttons. In my opinion, this is some kind of autocomplete. So instead of having it in the search while you're typing, you already clicked enter, right? So it gives you it here afterwards as a way to refine your search and go even deeper in what you're looking for and having the match better for you. Google also have this thing, Google Now. In here, when you have these results, you can do a very interesting thing. Before what they had is this on the left side, where you can just give a feedback of, I'm not interested in this topic as a whole. I'm not interested in this source as a specific source. Now they even change it more to have this option of having more than that or less than that. I find it's much better UI, in my opinion. It's more constructive, it's more focused. You can exactly tell it what you want, but still, it's lacking something, in my opinion. So during these last 2 days, we basically had one repetitive motto, to understand our model. And we had some ways to do that. The PWS, PwC, showed LIME, for example. LIME is a short of local interpretable model agnostic explanations. What is happening there is that it just takes your model, run all these predictions on it, and make some statistics to see which features are contributing to which result. This is a very nice model. This is a very nice tool to have it, to explain your model. It also enhances a bit the user trust because you can actually see if this model works on different scenarios. But this is not the last word. So PwC was talking about it. This is not the last thing. This is from 2016. There's a new boy in town. This is the SHAP. It was introduced last year in NIPS. I think now it's called NeurIPS or something weird like this. The conference. SHAP is a different approach. It doesn't look only on each and every single feature, but it also looks at a combination of some features together. The whole idea there is taken from game theory, and that's also the source of the name is after Lloyd Shapley or Shapley. I'm not sure if my pronunciation is correct, where in game theory, they're looking at coalitions. Let's say that you have now the G20 and Russia and the UK are doing some coalition against, I don't know, the US, for example. And we want to measure how much this coalition counts compared to the other votes of the other members. So this is in game theory, and they have the equations for this. So they implemented the same thing on the features. And then you can see not just the impact of one single feature, but actually a combination of it. Of course, there's a problem. When you do this on large amount of features, we are talking basically about a factorial number of features, all the combinations, all the permutations of every feature with the other features. If you're interested in this, I'm not going to go too deep. It's late. It's the second day. It's already 6:30. You're all tired. You want to go home to watch Netflix. So I really encourage you to go look at it. Simon already mentioned it in his talk, so you already knows more or less what's going on and what it is about. But this is a very good tool to have explanatory of your model, to see not only which words contributed to which result, but also which pixels contributed to which classification of the model. In the last year, I was working on this open source project. It's called Keep Current. It's made of a series of meetups that we are having here in Vienna, where we encourage people to learn by doing, actually come, take the open source code, and start doing stuff. We also have a monthly seminar together with Rania here, where we are taking subjects and we just go really, really deep into this. We encourage everyone to just read the papers before they come, because otherwise it will not be interesting enough. And we have a list of papers every single time where you encourage to read. We are going really deep into the stuff and learning machine learning even deeper. You are more than welcome to join. Look us up in the meetup.com. In addition, we are planning to start a course soon. It's based on fast AI. So if you're interested in machine learning and you want to, if you are developers interested in machine learning and you want to enhance yourself, also tell your friends. The whole idea is to have the fast AI course. You do it at home, you come to the class or to the meetup, and we are just discussing and going deeper into this topic. In addition, we also have the Keep Current itself, which is an educational project where the target is to have a filter of all the newest academic papers. Because at the moment we have a problem, we have Mendeley, I know, we have ResearchGate, but there's nothing out there that is give us the newly papers that just came out but filtered and as a recommended to you. Sorry about that. What we are using is some sort of recommendation system. We are experimenting and using different methods. For example, collaborative filtering. It was already mentioned today in the recommendation system meetup. We're using content similarity. For example, we convert everything to all the words to vectors, or the sentence to vectors, and then we check the similarity between the vectors. We're using the RNN. We're using more than this, the user feedback. These smileys here are a way to get the feedback from the user, just to say how good was the result for them. Was it, are they happy with the result, or or they're very, very mad on it? How do we get the data? So we already had a talk today by Alexandros. We use a topic extraction, for example, to do dimensionality reduction. We're checking also other methods, such as Elmo or BERT, just to look at the attention level and to have the comparison between them. And in order to measure all these vectors together, we can use, for example, Spotify Annoy, which is a really cool shortcut of approximate nearest neighbors. Oh yeah. The whole idea there, by the way, is that what they're doing is a cosine similarity of the RNN. I don't know if anyone used or know it. It's doing cosine similarity on scale. So if you have like a lot of documents and you want to measure the distance between them, but in a scale version, it's an open source project. Look it up in GitHub. It's a really cool thing. So how do we get the input from the user? We just ask them what they are interested in. The same way like it's like in some sort of a search engine. You can enter your topics, what you're interested in, and then afterwards we are comparing also these topics to other topics using vector distance, cosine similarity, or Euclidean distance. Word mover distance, we actually discussed it in the last meetup, and also a new method called PEEP. I assume that none of you knows what PEEP is, simply because it was just introduced yesterday in the NIPS. If you're interested in this, it's a new method of not only for measuring the distance between vectors, but also to understand what is the right size of the vector size for your word embedding. I really recommend to read this paper, very interesting, and also take a look at the method. PEEP. So I know that NIPS 18 is not called NIPS anymore. It's called NeurIPS. So it was happening yesterday. The video also exists in Facebook, and that was happening while you guys were partying last night. Also about NIPS, just a small thing. These are the type of things that can only happen in NIPS. You can present your paper while the god stands behind you, Geoffrey Hinton. So what else we had here in the conference? Also today, we had augmented intelligence by Simon. We had the human teaching by Shai. I call this stuff human-machine interactions. This is based on the work of a professor I especially appreciate. Her name is Ofra Amir. She's a professor in the Technion in Israel. What she's talking about is how we can not only interpret these decisions, these models, but how can we summarize all these decisions together into one methodology, into one strategy, how we can explain the user eventually what is the strategy of our model at every single moment. And this is not exist yet. This is only the research topic, and it's at the moment starting to get heated, and I think that this is the next big thing, and I encourage all of you to start reading about this. There's also, these are the two titles of the papers by her. Not only to research about it, I also encourage you guys to start building stuff using it. So I met her for an hour of a talk, and I showed her the project, and then I showed her everything that we're doing, and I asked her, what do you think about, human-machine interaction? What do you think about my UI? And her answer was more or less like, OK, so what would you suggest? What could be better in this? And she showed me really interesting things that are at the moment happening. I showed some of these methods in the beginning of like how to do UI that is more interactive, how to make the user be more engaged to your model, and how to make the users also give you voluntarily more information about this. So we had to change our UI, and this is what we did. What we created instead, when you are looking at a certain result, you have like a small button. Why did I get it? When you're clicking on this button, what you get is this screen of explanatory screen where we show here not only which keywords that you selected are matching to this document, but also which keywords that you haven't selected that can match this document, and which keywords that you have selected are not a match, as a negative match. And through this, you can adapt and adjust your model to you, so you get better recommendations the next time. Also leads to stronger engagement, and we encourage the user to give feedback and everything. So I know I promised what is an RNN vector, but this is a very heavy topic for this time of hour at the second day. So I promise this is not lost. The whole idea of the RNN vector is based on Yoav Goldberg's work and his presentation in Israel about a month ago. And I promise I will talk about it next week in the DSI Win. So just to wrap up, although I have a lot of time, I know you are all tired. Models can do mistakes, and it's our responsibility, as you heard from Moshe Vardi, it's our responsibility to take a bit of action and to make sure that our models are good enough. Interpretability is at the moment the only tool that we have. What I suggest is not just use it to understand your model by yourself, but actually integrate it into your UI, use it to show the users why they got the results that they got, why did they get the recommendations that they got, and also make it interactive. Make the users give you back information through this, so the next time they can find something interesting to watch on Netflix. So for the future research, where we're heading with this, we are looking at not just local interpretability of a single model, but looking at the idea is to create a summary of the agents, summary of the models, and to explain to the user what the expected prediction would be under different conditions. And now I ask you guys, after these 2 days in this Congress, after all this information that you have gathered, what will you create now? Thank you very much.
Thank you, Liad. Thank you very much. And yeah, so that was it. But before we close, just wanted to begin again. Every closing is a beginning. But just wanted to say a few words because I find this sentence very beautiful. Behind every amazing tech innovation today are developers, those unique creatures that know how to turn coffee into software. Using code as their primary instrument. So with that belief, with that philosophy, WeAreDevelopers is actually hosting a World Congress every year in the summer. And it is dubbed by many as the Woodstock of developers. Sounds really cool. And this year, in 2018, it was actually huge. It was brought together 8,000 techies from 70 countries for 72 hours of pure dev fun with more than 150 of the brightest minds in tech and the largest playground for developers in Europe. I personally think that sounds like heaven. So WeAreDevelopers World Congress 2019 will be held in June 6th to 7th in Berlin. So please keep your calendars open for those days, and please don't forget to register. My name was Caitlin Chang, and it was really a pleasure and an honor to host everybody here today. So for the past 2 days, it seems like we talked a lot about machine learning, and we come from all different backgrounds, but I think we do have a common denominator. And it seems like we're all sitting here, people who really love to keep learning. So please don't forget that, and thank you very much, and let's keep learning. Thank you.